Welcome to my channel. Today I'm going to continue my series about how to set up a grid. I'm going to use this grid to write a very simple bare bones role-playing game, but it can be adapted for other uses, for example, a chess game. Changes. Okay, I've changed the code a bit since my last video. I've put a link to that video in the description below. Last time I didn't use classes. You don't need to, but I think it makes code easier to read, easier to debug, and the program as a whole easier to think about. If anyone objects to my using classes, leave a comment and I'll see what I can do. Another change I made was that instead of having one function draw the entire grid, each class now takes care of this for itself. By the way, I've included a few links in the description below about classes and class inheritance. So, first, we set up our classes. Grasses, walls, and player. We're going to access these classes through the game class. You can see what's happening. First, we set up the game class, then we initialize each of the other classes and assign it to the game class. This means that each variable will be an instance level variable within the game class. Here is the map file I'll be using. This file and all the program files are in my GitHub repo. I'll leave a link to that in the description. Let's go through this step by step. Here I'm initializing the game class. These are the first 5 lines. I've covered this in my previous video, see the link in the description, but it's self-explanatory. I'm initializing Pygame, setting my caption, setting up my sprite group, setting up my display surface, and giving it a default color. The default color helps show if a tile isn't being placed correctly, so I like to set it to a color I'm not going to use for my tiles. Here we initialize 3 classes: grasses, walls, and player. After we've done this, we assign the object that's created to an instance variable in the game class. I'm going to step through the initialization of grasses in some detail. When you understand what I've done in the grass class, you'll be able to understand both the walls and player classes, since they work along the same lines. First, we create the empty list we're going to store the grass objects in. Next, we get the file path for a map and read it in, being careful to take off the new line character at the end of the lines. Here we're looking at each tile in our map. If the tile is either a period, which stands for grass, or a capital P, which stands for the player, then we give it a grass tile. You might be wondering why I'm creating a grass tile for the player. Well, since the borders of my player's tile are transparent, I need a grass tile behind it, or the background color will show through. So let's talk about initializing a grass tile. The grass class is a subclass of Pygame's sprite class. There are different ways of initializing the subclass, but here I use super init. Like before, I create the file path and load the image. Here I've been a bit more careful reading in the image, but although it takes more time, I found that it's a good idea to write code that will raise an informative error and stop the program if something goes wrong. Over the years, I've discovered it saves a lot of time and frustration. Here we're just making sure the tiles are the right size. That's the first line there. Then we're setting the shape of the rectangle, and then this is the last line. We're moving the tile to the correct location. Now we take the grass object we just created and add it to our grasses list. And that's it for grasses. Now let's talk about the walls class. I'm not going to go over the walls class in the same sort of detail as I went over grasses, because it has the same logic as the grasses class. If you have any questions about what I've done, leave a comment and I'll get back to you. Now let's talk about the players class. By now, this is going to be familiar to you. It's more of the same, so I'm not going to step through this function. Again, if you have any questions, leave a comment and I'll respond. At this point, we have finished initializing the game class. Now let's create a group that knows about all the lovely objects we just created. This brings us to the update classes function. In update classes, we combine all the sprites we just created into a group. This will come in handy later when we want to update all sprites and draw them to a surface. Now we're getting to the meat of things, the game loop. Here we implement the game loop. The idea is that we do 3 things here, and we do them over and over and over. First, we process the inputs, then we update the game world based on those inputs, and finally, we generate outputs. Let's go through this step by step. The handle events function is where we process the inputs, so let's take a look. This is an important function. Here we take in all keyboard or mouse input. Right now, I'm not incorporating mouse input, though I plan to sometime down the road. Let's dig into this. Here we just ask Python to grab any input. If it is a quit event, for example, if a player presses the escape button, then we call the quit procedure and return true. You obviously don't need to return true because calling system exit will quit the program. I included this line because in one of the next iterations of the program, I may change the structure of the game loop so that returning true will be relevant. Here, it's basically just a reminder to myself. Feel free to omit it. A lot of the functions I use here are from Pygame. As you see, we're rotating the image depending on the player's current orientation. For example, if the player presses the left button and the player is facing down, then we rotate an image a negative 90 degrees. Doing this turns the player tile left. The logic behind this is pretty obvious. If you have any questions, leave a comment and I'll go into it in more detail. After we have rotated the image, we need to move the tile and reset the direction the player is facing. The most important function here is collide with walls, so let's take a look at it. Here we just want to know whether the player's new position would put them inside a wall. If it would, then we return true and the player doesn't move. Otherwise, the player moves. Now let's look at the move function again. If we've determined that the player won't collide with the wall, then we update their coordinates and set the size of the image. I also use the print command to tell me that the player has moved and by how much. Whether you want to do that is up to you. Okay, we're almost done. Now we just have to commit these changes to a Pygame surface and then update the display. The functions here are part of Pygame. This is the great advantage of including your sprites in all sprites. Just 2 lines and you've drawn all your sprites. But nothing will happen unless we update the display. And that's it. Now run your program. Take your player for a walk in your newly created world. In the next video, I will add monsters for the player to fight. I've uploaded all the files I've used to my GitHub account. You can find the link in the description below. Thanks for listening. I would really appreciate your feedback. What sort of programs are you interested in writing? Do you like these videos? If you could suggest one thing that could make the video better, what would it be? I'll talk to you again in the next video.